Hello everyone, welcome to yet another video on the machine learning basic series. So in today's session, we are going to look at how to measure the accuracy of a regression algorithm. You already know the two major types of Hello everyone, welcome to yet another machine learning basic series video lecture. You already know the two major types of machine learning, which is basically regression and classification. So the way to measure the accuracy of a machine learning model differs between regression and classification. After all, accuracy is the most important thing in machine learning. We are building a prediction model. We are trying to predict. We are trying to predict sales. We are trying to predict diseases. We are trying to predict whether a product will succeed or fail. So we are trying to predict. So when we are trying to predict, accuracy becomes very, very important. If the accuracy is low, why would anyone spend time, money, and effort on building a machine learning model, right? So accuracy is of paramount importance in machine learning. So coming to how you measure the accuracy in regression, let's understand that regression involves numeric value, right? A classification involves a non-numeric value like yes, no, right? Good, bad, go, no go kind of scenario. So we are essentially talking of numeric values in a regression algorithm. So how will you measure the accuracy of a regression algorithm? We use three different types of metrics. One is known as coefficient of correlation. Okay. Coefficient of correlation, also known as R. The other one is known as coefficient of determination. Okay. Am I writing this correctly? Determination. Coefficient of determination represented as R square. The third one is root mean squared error. Okay. Root mean squared error. So we look at all three to assess the accuracy or how good the fit is. R tells me whether the relationship is positive or negative, right? Coefficient of determination tells the goodness of fit. Okay. My RMSE tells me the absolute difference between predicted and actual. Okay. Suppose if there are 10 data points that you have predicted, so for all the 10 data points, you find the difference between actual versus predicted, and that average is the root mean squared error. We square this because sometimes you can have negative values also, right? The difference between predicted and actual can sometimes be negative also, which is why we square it and then take a square root, right? Suppose, for example, if the difference is -5, -4, +5, +4. Let's take, for example, this is the difference between actual versus predicted. If I add all of this, it will become 0, right? So the accuracy is not 0 in absolute terms. There is a difference. So what I do, I square this. 25, 16. So I square, sum everything, and then take a square root. That is the root mean squared error. So as I said, coefficient of correlation, the value can be between -1 to +1. Okay. Whereas coefficient of determination is between 0 to 1. How will you explain this positive and negative relationship, right? taking the student example itself, a student studies more number of hours and scores less marks, right? The more number of hours the student studies, the lesser marks the student gets, right? That is a negative correlation. The more number of hours the student studies, the more number of marks the student gets, that is a positive relationship, right? Taking it to a healthcare example, I give a medicine, the disease deteriorates, it's a negative relationship. The medicine is given, the person's health improves, that is a positive relationship, right? So if R is closer to -1, it is tending towards an absolute negative, or if it is closer to +1, it is a positive, right? R square, as I said, it shows the goodness of fit. Okay, a student studies and studies many number of hours, scores less marks. A student studies more number of hours and scores more marks. Those are the two scenarios, right? Whether it is really good marks or average marks, right, or just pass marks, that is the goodness of fit, right? How good is the relationship? If my R square, let's say, is 0 or closer to 0, 0 or 0.1, it means there is no relationship, right? It means that the fit is a poor fit. If it is 0.5, it is an okay fit. On the other hand, if the fit R square is 0.8 or 0.9, it means the fit is good, right? That is the equation that we have got for the regression algorithm can be used very well to predict the future, and it takes into account all the data points, all the trends and all the patterns that exist in the data set, right? So if a model captures all the trends and all the patterns, you will have a higher R square. If the equation or the model doesn't capture the trends and the patterns adequately, you will have a lower R square. So please keep this in mind. Okay, R is to tell whether the relationship is positive or negative. That is all. It is R square that tells the goodness of fit. Okay, and RMSE is in absolute terms, right? I need to look at all three. Don't be satisfied with just one or two. Okay, look at all three so that you get a clear idea about how to assess the accuracy of a regression algorithm, right? I hope this is clear to all of you. Okay, when we come to classification, we look at a different set of metrics. Okay, we will cover that in a subsequent machine learning basic series video. Okay,